Our project for today is to get this old forklift running. Not getting any fuel out. I definitely have fuel coming in. This is the magic of the rotary injection pump. Yeah, she's not coming out of there. So that's the problem, and the overall condition on the inside of this injection pump is horrible. That's it. Hope we got that on camera. It runs okay at high RPMs, but it just runs out of fuel. So there's something wrong with the pump, the injection pump, I think. So I don't know what the problem is. I think there's an issue with the transfer pump section, and we don't have enough transfer pump pressure or enough transfer pump flow. So it needs to go to a professional. So probably... Alright folks, I got the world's busiest road, and what I can only assume is some kind of Gatling gun going off behind me. But we're going to try to push through it. This is a Clark UT60D all-terrain forklift. If you guys recall, well over a year ago I made a video where we tried to get this machine running. And I believe the fuel that was in it at that time was over 10 years old. We took the injection pump off, took the pump apart, cleaned all the parts, put it back together, put it back on the machine, and we kind of sort of got it to run, but not really. It would only run at high RPMs, it wouldn't idle down, we couldn't do anything useful with it. There was still a major problem with the injection pump. It also had a problem with the starter motor, it wouldn't hardly crank over, the battery was kind of on its last leg. The only way I was able to get it started was by 24 volting the starter, which obviously isn't good for it. Anyway, today's the day. I've gotten some help with the injection pump, I bought a slug of parts, we're going to try to get this thing running. Mother Nature's working against us a little bit. It's warm today, well above freezing, but we still have a lot of snow. I've had to pack everything in. I can't even get my truck in off the road. So anyway, let's get to it. Now, if you guys remember, one of the big problems I had with this machine is it just cranked so slow. And the only way I was able to get it started was by hooking two batteries in series and feeding 24 volt to the starter. Anyway, I took the old starter off, took it down to my local auto electric wizard. He took a look at it and said, basically, here's your options. You can rebuild the old starter. It needs everything, solenoid, armature, bushing kit, whatever. Or you can buy a new one. And the new one's a gear drive starter, and it's going to crank over a lot faster. Price is about the same. So I ended up buying a brand new one. This is a brand new starter. It's been sitting around for a couple months, so it's getting a little bit rusty. Anyway, we're going to slap that in. I also bought a brand new battery. This is a Group 31 truck battery, stud top. We're going to have to convert the terminals over because it had the old, whatever, clamp style on it. Yeah, I like these because they have a little more capacity. The old battery was a 29H. This has a little more amps and it's a lot cheaper. Hopefully that's right. Memory's a little foggy. Also, this is a new fuel filter. That'll work just fine. These are 2-aught battery cables. Not sure why it has such massive cables on it, but there used to be electricity down here. Not anymore. So, I guess I can't shrink these. I don't have any matches or lighter or anything like that. That's okay. Skip it for now. Well, what do you know? Did have a lighter. Looks good enough. Well, by far the biggest component in getting this tractor to run, or this forklift to run, is the injection pump. And this is where I had to have some help. So here's the story of this injection pump. Long-time viewers will remember I did kind of a major tune-up on the old L10 Cummins engine in my rollback truck, and part of that process was replacing the injectors. It had STC unit injectors. They're hard to find. They're obsolete from Cummins. Not a lot of places rebuild them. Anyway, I was recommended to check out Area Diesel Service, and that's where I ended up buying those injectors. Well, flash forward a couple of years, Area Diesel Service is now on YouTube. And they've seen some of my videos, and they reached out to me and said, hey, we can probably help you. So earlier this week, my dad and I took a road trip down to Carlinville, Illinois. It's about 3.5 hours south of me, and we got to tour the Area Diesel Service shop, check out their operation, and we watched a master injection pump rebuilder rebuild this injection pump.
We are a fuel injection pump and injector rebuilder and distributor, as well as a turbocharger rebuilder and distributor. So we're a job shop, we're a repair and return facility for folks that need service work, and we're also distributing these parts. So a lot of what we build is for stock, high running, common commodity type stuff. So we're a little bit of both. We're a service and repair center, and we're a parts distributor. 50 years strong. Kind of a neat story. Val Leifers founded, one-man operation, a true entrepreneur, and today there are just almost 50 employees total. We're in 3 locations. We're in Carlinville, Illinois today. We've got a shop in Des Moines, Iowa, and we've got a shop in Indianapolis, Indiana. So
I brought my grip along.
Here we're in the original facility. This is what is now mechanical fuel injection. So this is administration, customer service, work orders, parts acquisition, trouble solutions type of thing. So a couple of folks here that kind of spearhead. We have a number of rooms like this that are tooled up for a variety of pumps. So they commonly do inline pumps here, and you'll see they've got the appropriate wrenches, microfish, loose parts, special tools. They're tooled up for just a specific couple of products. So a number of cells like this. Over here is traditional calibration. So really kind of similar to like an engine lathe, but it's a test stand. In here we're calibrating fuel delivery, we're turning screws, and we're looking at fuel coming into these graduates, and we're seeing how much fuel and if it's balanced. So vintage test equipment here. This little cell is mechanical fuel injectors. So pop tester over here in the corner, all the right wrenches and sockets, gaskets and washers. This is almost exclusively VP44, so it's a little bit more modern technology. This is Rick. He's probably built more VP44s than anyone alive. So now the equipment is a little bit different. So instead of turning the screw and looking at a graduate, we're using a computer to measure delivery, and we're changing calibrations with the computer. These are Bosch 815 test stands. Of course, none of them are running right now, but generally those pumps are turning out just as much product as we can go. So, same story, these rooms are tooled up for a couple different types of pumps. So,
these are all BP44 parts?
Most of them, yeah.
Most of them, okay. Wow.
There's some standard.
So this is Corey's room. It happens to be a rotary pump room, and you'll see your pump back in here shortly. Clocking in and out, adding parts to work orders, engraving data plates to the common area. Different style of pump. Different style of pump here. Another technician room.
These are experts on a specific style of pump.
Yeah, usually, you know, maybe 2 or 3 pumps a technician will focus on. There's a lot going on in there. The part count is really high. Memorizing where all that stuff goes. There's only so much a feller can stick in his brain, I guess. So.
Yeah.
Tear down, obviously, and each of these cells kind of replicates one of these build-up rooms. So we do the dirty work out here, try and keep the crud and grease and broken seals and gaskets. So we'll scatter them. You actually see your pumps right here. Corey's already starting to prepare to blast and clean up. So tear them apart, clean them up, and then bring them up to the rooms where we try and do the assembly and keep things a little cleaner. So this is kind of Grand Central Station. We have 3 different locations here in town and then 2 other locations in different states. There's a lot of product shuffling around, having different processes done here and there, subcomponents going up, cores coming over. So we've got a core facility. We got production orders. They'll shuttle the cores over, tear them down, they'll go over to distribution and get sent out. A lot of shuffling. So this is kind of where that takes place. So we're in turbo teardown, similar model, administration. So service riders, customer service, finding parts, dealing with all the things associated with the turbo department. So this area here is turbo teardown. So they come in greasy, dirty, and broken. It might be one at a time for a repair and return, or it might be 20 pieces for a production run. But this is where it starts. So it's dirty, disgusting benches. Scatter them, tear them apart, throw away the scrap. We'll bake the components, get them cleaned up, and then we've got just about every type of abrasive we can come up with. We've got shot glass, plastic bead, traditional sand, I guess you would say. We have soda blasting. We got to get everything cleaned up so it's presentable and we don't bring any of the failure into the remanufactured component. This is assembly. So you'll see a variety of things here. You'll see a 1-piece repair and return, or you'll see 10 pieces staged for production, but this is the clean side of the operation. So everything's been machined, fixed, blasted, cleaned, get some new parts out of the warehouse. Okay, so a little bit of inventory here. This is what we call an A part. A lot of the remanufactured units that we build for stock, we first start by tearing down the core and salvaging the subcomponents. So this is all out of a turbo that has previously lived. We've torn it down, we've inspected it, we've cleaned it, we've machined it, we've confirmed that it's worthy of another life cycle, and we stock these subcomponents so that the customer service folks can determine what units we have the capability to produce. So bearing housings, back plates, compressor wheels, turbine wheels, clamps and heat shields. And this is just one particular manufacturer of turbo we've got here, but we're a rebuilder, so the more we can save, the more competitive price we can bring to the market. So in between the teardown and build-up operations of both of those departments, it became pretty obvious that we were throwing away a lot of material and we were buying a lot of material that really could have been saved, fixed, or repaired to make us more competitive and to allow us to remain profitable and stay in business. So many years ago we started with what was probably a drill press and a benchtop lathe, and we started fixing shafts and housings and threads and relatively minor repairs, but it just, you know, necessity was the mother of invention there. So what that has developed into now is a pretty modern, high volume machine shop. We service primarily our own production departments, but we also service other shops like ourselves. So people sublet their housing repair for their pump rebuild to us, and a lot of custom modifications. So we do performance turbocharger, let's put a bigger wheel in it, or I need a different discharge flange, and short run production, obsolete parts that you can't get a hold of anymore, or custom components that we might use to salvage a component. Just different creative ways of saving a dollar, saving a part. So we'll kind of walk through and look. This is a P-pump housing. This is for a conversion kit. We take a caps pump off, we put a P-pump on. And they're making some modifications to facilitate that. One of the major ones, this pump didn't have a supply pump provision, so we're milling that off, drilling and tapping for a supply pump, and then they make some other changes to them as well. Similar model back here, administrative area, work orders, customer service, keeping the production guys going basically. Turbine wheel balancing, or I guess turbine and compressor wheel balancing. Got a strobe light, kind of looks like a timing light. Put a little sticky weight on there. That's where we do the first step balancing. We also have a VSR or a high-speed cartridge balancing machine as well. So, Wes probably knows more about some of this stuff than I do.
That's a Miltronics flatbed CNC lathe.
Yeah.
Looks like a nice one.
So compressor cover work, turbine housing work, modifications, repairs.
I had no idea you guys had this capability.
Yeah, this is my favorite place to come, mostly because I don't know anything about it. So it's new and different to me. But, okay. This is also a lathe with some type of live tooling. What do we call it, Terry?
This, the machine, or
what can it do?
This can do just about anything. The stuff over there, if you look on that shelf, are some of the projects we've done. We literally just got doing them on here. Right now it's doing this here. We'll put one in there and it'll come in and do the ID of this. It cleans it up, gets it to size, and then we'll send it off to our customer.
It's a 6-liter high pressure oil pump billet housing.
That's the finished product from after it gets put on here.
Wow.
5-axis milling center, milling station. You probably know more about what that means than I do.
It's a good one. Got the old pedal over here.
Gotta have one of those, right? Mini mill, another milling center. The Easy Pass, that's a workhorse. That's been a great machine. Done
Sure.
a lot of cover and housing work on that. EDM. So in our industry, this is commonly used for enlarging nozzle orifices, but we don't do that. We use this for a housing repair, injection pump housing repair, and we'll see that operation next. Turbine wheel shaft straightener. So we check them for straightness, read it out on these indicators. Kind of like a hydraulic press, but really super sensitive. Put a little bow back in them, turn them and check them. They've got memory. You got to let them rest a little bit.
Wow. This is, an operator has to do that basically manually, right?
Yeah, yeah. There's the business end right there, yeah.
That's very cool. I've never seen a machine like that.
That's a process that not a lot of our competitors are doing. They may check them for straightness, but if that machine is a little bit, I guess, unique amongst our industry or competitors. So doesn't look like much, but it's obviously at 100,000 RPM, straightness is going to be a pretty critical component for success. So.
Right.
So grinding,
yep.
Shaft undersized. This is a cylindrical shaft grinder. That is a surface grinder, and then that I believe is a second cylindrical shaft grinder.
Yep.
Can't have a shop without a couple Bridgeport type mills. Small fabrication area. We do welding for build-up repair. You've got a catastrophic failure and it eats the material out. We got to put material back to machine, so we do that with welding. A little bit of material here. This is the housing repair that we use the EDM for. And somewhere, okay, so there's an orifice or a passage plugged off here. Inside this passage is like a 13,000th orifice, and it plugs up. So we'll take that EDM, we'll burn that ball out, we'll come in here and burn that orifice out, clean that passage and put a new orifice in it. And then the major mode of failure, so this is VP44 for all you Dodge folks. The timing sleeve is the mode of failure. So we're machining the housing off, pressing the sleeve out, putting an undersized sleeve in it, machining the advanced piston to fit, along with a couple other updates, and now we've got a remanufactured housing to feed to the remanufacturing department. So. Okay, warehouse. So when these components come out from these other departments, this is where they stop by first, and you can see a batch here. This has just come out of production. These are units remanufactured, tested, verified, and ready to go. Got a packaging station here where Mike loves to do his job. Expanding foam. Packaging is one of the most important components of quality. It's got to get there. It's got to arrive in good condition. So,
wow. You said you have more inventory besides just this?
Yeah. So Indianapolis and Iowa both have a pretty large offering. This is probably, it's getting close to not being definitely the most we have in one place, but it's a good chunk of it. See here we've got orders staged that are getting ready to head out.
Wow.
We're a little bit tight on space. That's kind of one of the reasons it looks like this. So
that's a good problem.
It's a good problem. Yep. More subcomponents from the turbo shop. So these are previously lived A parts for remanufacturing. These shelves are pretty well finished turbochargers, ready to go, whether we bought them or built them. These are in stock, ready for delivery. We start to get into new turbocharger components. You can't save everything. Got to supplement some of it. Service components and piece parts, bearings, there's 100%. We distribute those and consume them internally. This is one of our brands. So this is a common type component you would see come out of our machine shop. So this is a turbocharger compressor housing discharge mating flange. And a lot of folks we trade with want to put a turbo where maybe it shouldn't go, and they need the plumbing components to facilitate the turbo.
Someone like Rich from DeBoss Garage, maybe he would be, you know, putting 4 Frankenstein turbos on a car.
Yeah, yep. So all of the plumbing components, and this is a brand, so this is Axis Turbo Accessories. These are cataloged and distributed, but exactly that. I want to put a turbo on my lawnmower, and I got the turbo, I just can't hook it up. So oil flanges, exhaust connections, V-band clamps that you can't ever find at the right place at the right time.
Right. Very cool.
Whole line of that. So, and then fuel injection smalls, again supporting the fuel injection shop, but also servicing the people that do, like Wes, need a gasket kit or delivery valve, or they're making their own repairs.
But what's cool is that, you know, you guys can just do everything. You don't have to wait for parts or...
And a lot of it is, you know, like a fella like Wes will call and say, I've got this pump off an Oliver, and I need this O-ring behind this shaft, and I need this valve on the top of the pump. Well, our customer service folks have the ability to break that pump down, get the bill of materials, and supply the individual components. So it's a service that we offer along with rebuilding the pump if you don't want to tear it down. So.
Alright guys, tour's over. We're with Corey. He's got the pump here. He's blasted the outside of it, cleaned it up. So if you don't remember, the problem that we had with it is, well, initially I took it apart because the plungers were stuck. We freed that up, freed the metering valve up. I kind of maybe sort of got it to run, but it just wouldn't stay running above a certain RPM. So he's got some theories about what that might be, and he's gonna tear it apart and hopefully give us an answer.
Hopefully. What I typically do to start with this, we blasted it just to get all the dirt off, make sure that it's nice and clean, at least on the outside, just makes it easier for me to handle. Then I just kind of start at the top, work my way down through the pump. I'll take the fittings off. I made just a mental note, wrote it down even, of how these fittings went, because obviously we want to get them back in roughly the same place, make it easier for the customer. A lot of these return connectors I almost always replace because they get crap in them. Like this one's pretty nasty, and
it's basically a check valve, right?
Yeah, and it's one of those, if this gets plugged up, then it'll hydraulically lock the pump and it'll make your pump die. So that's why it's easier just to replace them than to mess with them and try and reuse them. They're a cheap part.
That one's a throttle stop?
This is your low idle screw.
Okay, because I think the other pump I have doesn't have that screw.
Yeah, not all of them do, because your other pump off the Oliver, it runs everything off of your throttle lever.
Okay, so they just separated it out on this pump.
It's just application based. It depends on the pump, honestly. My other pumps I'll use a lot of power tools on, but... So luckily this is the newer style solenoid, so that's good. Normally I don't have too much problem with these. As you can kind of see, that it's a little gummed up. It's not quite as bad up top as what I thought it might be, but...
I've seen it when I first did it. I spent more time cleaning it than I did anything else.
And cleaning it is important, because if it's not clean, then it's not going to run. It's just how it is.
Okay, there's a gasket or something that you're going to have to replace.
Yeah, there's a actual seal on the stud itself.
Okay.
And then there's an insulator on top to keep it from grounding out. Let's pull it out here. So we got the two little rubber grommets on here. That just seals it on the top cover itself. And then, like I said, then these insulators here literally just keep it from grounding out on the top cover.
Yeah, I'll take care of all this when I do to put the video together.
Got our clip here. It's just a retaining clip to keep all these levers on. Sometimes I replace those and sometimes I don't. Don't mess with anything more with that. Once we go back to building it, I'll check that spring, because those springs do wear out on those throttle levers. Can get this loose. This holds your low idle spring.
Okay.
If you didn't know that.
So where I stopped short was I thought maybe the transfer pump pressure was too low. And I didn't have a way to test that. It's adjustable, the regulator on this one. Whereas the Oliver one is fixed, I believe.
Well, yes and no.
Okay.
It is fixed in a sense to where there's not an actual screw, but on the end plate there's a plug that has a height adjustment.
Okay.
So it goes from a 0 to 8.
Okay.
So 0 being the lowest plug, which will give you the least amount of pressure, to a number 8, which gives you the most amount of pressure.
That's the primary pressure we're talking about.
Yeah.
From the tank.
No, from the transfer pump.
From the
here.
transfer pump.
Yeah. That's
Yeah.
what I meant. The first boost of
Right.
pressure.
So into the rotor. Right?
Yeah, exactly.
So I didn't have a way to calibrate that, obviously, and the book has some kind of lame set it
Explanation.
to the flush or something.
Oh,
Did you put a new metering valve in this?
No, that is the original. meter.
really? See, because it looks like it's in really good shape. A lot of times those are worn out. Basically, I start here so that once I get to the advance, it's flat.
Okay.
And it's just easier for me to work on it. Because, like, I do it all on a bench, where some people will actually mount it to a bracket. So, also it's good that you guys got a steel plug in here.
Yeah, he told me that had been updated when I asked about parts for that.
Okay. Let me try and get this.
It just drives in, right?
Yes, but it drives into a preset point.
Okay. I
So
didn't take it out.
I
so-
have a tool that sets it to a determined depth.
Okay.
Screen came off. So this is what regulates the amount of transfer pressure you get and the curve at which it comes in.
Okay.
Because typically these pumps here, you know, at cranking, you'll get around 20 psi of transfer pressure, and then from, let's say, 75 would be 150 on the engine to about 1,000 on the engine. It's going to go from 20 to probably, depending on the pump, it'll go from 20 to about, 50
Okay.
in a short range. But then once it gets to its top point, then it becomes a real slow curve, and that's what regulates your speed at which your advance comes in. Yeah, I can tell you right now, this screw is turned out way too far.
Yep. You heard it, people.
Because,
Did you do that?
Yes, I'm sure it's me.
yeah, that was turned out a lot.
So I probably had the transfer pressure way too low. is what I was
Yes.
getting at.
Absolutely. Yeah, because that probably took me, 4 or 5 turns to bring it all the way out, and I preset those at 15 turns in.
Okay.
So,
Wasn't even on the spring.
no, it wasn't even remotely close.
Okay.
This plug is where you read your transfer pressure out of,
Okay.
at least on the stand. Plate just comes out. This is basically just a wear plate. Yes, this is the transfer pump itself.
Veins.
Right.
Yes. But your liner doesn't look too bad. A lot of times I have to replace these. Same with these blades. I'll just replace these because it's better to replace them than mess with them later and have them not work. So this is your adjusting screw, which determines when your advance comes in.
Do they all have that?
They all have some form of screw,
Okay.
where this one screws into the end cap, and there's a piece on the inside which pushes on your spring.
Okay.
Different styles, typically like on your international pumps, there is a rod that goes through your piston, and it encapsulates the spring, so this part doesn't come out of the piston itself.
And you'll get to that piece. Because we were really having starting problems for a long time with this engine.
Yeah.
I think I had to tap it with a hammer on the top to get it to crack loose, and then it came
Yeah.
out pretty good. It has a spec in the book.
Did you torque this in?
Yes.
What'd you torque it to? Do you remember?
We have a Ruse-Master book, and I did whatever it said.
Okay. Because if you torque that in too tight, it could seize the head.
Okay.
Stick this in so it's touching the housing. If you stick it in all the way, you'll go against the
Oh, yeah, I
ring
see that,
of the
right.
head, and you will not get it out no matter how hard you pry on it.
The one that I learned on.
Just like that. Okay, that'll work. So what you have is a flat washer.
Okay.
Some of these, there's two different designs. There's a flat one, and there's one that has a chamfer on the on one side.
I took pictures of all of that when we did the last one.
Okay, yeah, like you guys, this one has a solid weight cage, so did you guys already put this in previously?
No, it was there.
Oh, really? This cam is not the best either.
Okay, now as far as calibration goes, I did measure the height over the rollers.
The roller?
Yeah, with the micrometer.
Okay.
And I set it to the spec that was in the book that we have.
What was that? Do you remember?
It's in the video. I can look it up if we want to know what it is.
What's that you did?
So when you take that little leaf spring off.
Okay.
Now, did you do that with these pushed out?
Yes.
Okay.
I actually used air to push them out. Yeah.
Because you have to.
Okay.
If they're pushed in, you're not reading it right.
Yeah, the book tells you how to do that.
Okay. Just making sure.
I've never gotten that far either. We've always just left that stuff alone.
Yeah.
I've never had one with the plunger
So
stuck.
this is the part that was the problem for me, is the plungers were stuck.
Yeah, and they're stuck right now too. At least that one was.
Another problem with the transfer pressure being too low, it could keep those from pushing out.
Yes.
Correct? Yeah.
Exactly.
Now this is the delivery valve.
Did you take this out?
Yes.
Did you retorque this back in?
Yes.
Yeah, and it's stuck in there.
Yeah, it's also stuck.
I think it's coming out. You want to be careful doing this, because, yeah, it's coming out. Come on. There it goes.
What happens if it doesn't?
You have to get it out.
I know, that's what I mean. Is there an alternate method? Or?
Yes.
Okay.
So I have a tool that latches on the end of that, and it'll pull it out.
Okay.
So whenever I worked on this before, I noticed there's a little spot right here on the delivery valve that's kind of scored. I don't know what you think about that.
You're not necessarily looking so much here.
Okay.
You're looking at the top part here.
Okay, that's the
because this is more of the sealing surface, because what happens is fuel gets behind it and it lifts.
Okay.
So if this part is wore out, then it'll all go right past it.
Okay.
Or it will dump off prematurely and you won't get your fuel delivery.
Oh.
And this one here is where your return wire is.
Okay.
So
that helps bleed the pump out.
Yes.
Okay.
Exactly. And what it might be, I'm going to try and get it out right now. And if it doesn't, then I will have to, after I clean it, I'll try and get it out again.
Okay.
And then if I still can't get it out then you just have to leave it. Most likely it's not going to come out. If it does, I'll be surprised. Oh, there it is. With getting this out, it can properly be cleaned.
Right.
And it'll work better. Well, and if you would have came in to me off the street, said, hey, I want you to run this pump on the stand, I would have said, you're crazy, it's too nasty, I can't run on the stand.
That's something we didn't know, and now we do.
Because I physically cannot contaminate my stand.
Of course.
For the sake of your pump.
Of course.
I'm sorry.
No, we understand it now. We didn't before, but
I never even thought about that. That makes sense.
I couldn't understand that.
And basically what I'll do, I'll push this pilot tube out, and we'll put a new one of these in it as well. Every single pump I do gets a new pilot tube.
Okay.
And it's 5-minute epoxy, so it's pretty quick. Handy dandy tool, because this tube has to be set to a specific spec. Okay, good. Which, like I said, that head doesn't look the best, but we'll see if it works. Again, this is a brand new delivery valve, which there are different ones of these. Of course, this is the one that's correct for the breakdown for this pump. This is actually the tool that I would use to pull the delivery valve out if it was stuck, but it also has a spot where you can screw the screw in. So that has to be torqued to a specific value. Otherwise, if it's not torqued enough, then it could leak. If it's torqued too much, then it could seize the head. Neither one of those is a good thing.
So you had that out before.
I think so, yeah.
Just this is just calibration fluid. Because we can't use diesel fuel. We have to use a actual calibration fluid.
So your stand works.
So like it's a standard across everything.
Of course.
Make sure that's smooth, which that's a lot smoother than what it was whenever it first came out. But what we'll do, I'll put these plugs back in. Obviously now this wire is nice and clean. Okay. This is a brand new head O-ring. I just put it on there just so I don't forget it. That slides right in, which is good. So I usually just try and put the non-worn side out. Does it make a difference? I have no idea. It's just something that I do. Spin freely inside these shoes, because obviously if they're stuck, then it'll create a flat spot on them. Okay. So now, take this, and this is where you would have checked your roller before. You probably made something like this or hooked air to it somehow.
I just used a rubber tip on a blow nozzle and just popped it in there. It worked fine.
Oh wow. Okay, so yeah, so now you can tell that those have pressure behind them. Also, you got to make sure that this screw doesn't leak air.
On top of the delivery valve.
Yes. Which you are right on stock spec. Now, here,
At least I got that part right.
we always set these 5 thousandths over, and we found that's what actually gets us in stock fuel. Because typically the actual stock roller will get you under your horsepower.
Probably because of
Just wear and things like that.
Okay.
So, generally we always set all of them 5 thousandths over. So, since we're maybe wanting to adjust this a little bit higher, I'm going to go, you know, let's say 7 thousandths over and just see what happens. So the max you can get out of this one is 83 and a half, which is not very much, which that's about normal for the number of leaf spring that you guys have in here. So we will pull this out and put a bigger one in it. Gotta make sure that it is going on in the correct direction of rotation. So that is correct right there. Okay. Have you messed with this timing mark any?
that was going to be one of our questions.
So I have this graph here.
Okay.
It's a specific Stanodyne tool.
Okay.
And then if it was wrong, then I put a pencil line, I use an electric pencil, and I make a new line. So that's why we're going to see.
So if you put a new one on with no mark, you use that tool to do that?
Yes.
Okay.
Which this one here is within 1/4 of a degree, so it's actually pretty good. So, line the lines up.
Put one of those in that.
And then the snap ring. Sometimes you gotta check these because what'll happen is in between these two plates, this line here, it can create like a gap, and that can create problems, but very rarely does that ever happen. It's just something that you gotta watch out for. Of course, I have a tool that puts this in. And also you want to put this gap opposite of this gap, because if you put them together, then they could spread out. Okay. So, back to the top, back to the top. Put our weights in, which these weights look pretty good. They will wear out. They'll get a wear mark on the back side that'll travel up. And usually if these are wore out, then your cage is wore out. So basically that can create an erratic governor, things like that. So yeah, now we'll actually start putting things back inside of the pump here.
So in a working day, how many of these pumps can you fix?
These pumps here take me 4 hours.
Okay.
Roughly speaking. Some take me a little bit less, some take me a little bit more.
Pretty good.
I think the quickest I've ever done one of these is 3 hours. And that's, you know, perfect.
It takes us 3 hours to get them off the truck.
That's a perfectly clean pump. You know, that's...
Right.
There has to be several different things that filter into that. With these here, they have to go in the correct way. The knife edge has to face towards your governor arm. But yeah, usually my goal for these is to get 2 done a day.
Okay.
Try and make these even as possible. And you always want to tighten the right side last to bring the knife edge up. You don't want the knife edge to be down.
Okay.
Make sure this is kind of all in line, just makes it a little bit easier going in. Okay. So your metering valve,
So far out of our depth, it's not even funny.
I know.
your metering valve is still in pretty decent shape. It has just a touch of wear, but nothing that's super concerning for me. So stick that in there. Make sure that's free, which it is now that it's cleaned up. This is just a dummy shaft. You always got to tighten the bottom one first. I don't know if it says that in your book.
Can't remember.
The rural areas of Illinois where we were, it was a long drive to get to a place like that.
Yep.
What helps is that I have this bushing here, and that's what holds your screw and your bit straight. Another special tool, yep. It's just a...
Ring compressor.
Yeah, basically just like for a piston in an engine. It just collapses the piston ring so it's easier to put in. And then the flat side always has to face out, because otherwise there'd be nowhere for the slide washer to go onto.
Right, okay.
Just put a little bit of grease on top just to hold the slide washer. The power piston always goes on the side of rotation. So like you typically on these housings, which this one doesn't have it. Okay, yeah it does. It's like on the sides. So this is counterclockwise and this side is clockwise.
Oh,
so
okay. That helps.
That's a joke.
I don't even know the torque spec on that. Couldn't tell you.
Good and tight.
Good
Yep.
and tight.
Good and tight.
Good and tight.
Find
Oh.
that works pretty well.
One of the best mechanics I ever knew would come up to a thing like Corey's, the bench completely full of everything, tools, parts from several jobs, and he would go to work on a new one and he would push
Oh man.
until the stuff came off the end of the bench. That guy was a great mechanic though, but he had no housekeeping skills whatsoever.
Yeah, I don't like having a dirty bench. I can't take it.
You could not have worked with this fellow though, but boy, he was smart.
Now what are we... Hold on.
So basically we
put new veins in.
Yep,
the pump?
put new blades in here. Of course, 2 have to face down and the other 2 have to face up, because otherwise they're not going to go in.
I'm going to tell you right now that if you're thinking about taking those apart on the tailgate of a truck on top of some grass, those are small springs.
They are.
Even I haven't. Well, I should say warranty wired too. I
And those were
suppose.
never bent over.
Oh, really?
No.
They're supposed to be.
Oh, ugh. Reason I was in high school, I'm like 40 years of putting these tires on these.
You did them with 2 bars. I think they call it a Cobra.
This is the part that you had it backed out so far that it probably wasn't doing anything.
It's okay, just twist that knife, Corey.
So that
I'm gonna tell it to you so you don't forget.
so that problem was so
You gonna learn today, boy.
what exactly was that actually causing multiple problems probably?
So what was probably happening is that since you had this backed out so far at 2500 you need 90 psi. You were probably only getting maybe 60.
Okay.
So then because of that, you were probably only getting half the advance
Right. Okay.
if 3 degrees, if that. And your head has to have so much fuel supply to support the horsepower that it's trying to generate.
So everything would be
Yes.
wrong. Start with and ran pretty good. We have a good idea.
So, of course, gotta make sure you remember which side this goes on because this go on either side.
That's the thing that I would have to photograph.
But I always write it down.
Yeah,
That
right.
it was the same way with this one. I wrote down what color it was, which side the throttle lever's on, and which way the fitting's pointed. Of course, it has these plastic spacers,
Okay.
and that takes the play out of here.
Okay.
There is a limit. You can only... We generally rule of thumb is you don't want any more than 3 on each side, on either side, because then you're forcing that O-ring out further.
Okay.
So if you put too many on there, then it gets outside of its seal area, and then it'll leak, even with the new O-ring. This is how you check your linkage length, basically.
Okay, I remember doing that. I found something that was the right width and I checked that.
So this is right on the top end of the spec, which is fine. As long as it's in spec, it's all that matters.
Okay.
But basically that changes where it shuts off at high speed. So like, let's say if it wasn't shutting off at all, then that means that that's too short, I would imagine.
I mean, it's the name of somebody anyway.
Make sure that's...
Engine.
The reason why I replace it is because a lot of times if stuff gets in here, there's a spring inside of here.
Oh, is that the check valve?
Yes.
Oh, yeah. I've actually cleaned those out before.
Yeah. And I just never trust myself to get them 100% clean. So yeah, that's basically it for building your pump.
Cool.
Yeah, see how we got transfer pressure.
That you got on the left up there's your RPM deal.
Yes, this is my RPM.
Oh, okay. What's the one that you...
Basically run it for the start just to prime it. And you always start out slow just in case something bad is going to happen because you'd rather catch it right now than at 2,000 RPM. Good.
The test stand's pretty loud, so I'll try to explain what's going on here, at least as far as I understand it. Corey's running the pump at various RPMs and checking the delivery, the amount of fuel that it spits out to the injectors, and the transfer pump pressure. And they have to fall within published specifications. So the big gauge you see on the right hand side at the top, that's the transfer pump pressure. And he said really the most important readings there are at low RPM to make sure it's delivering enough fuel to the plungers to get the engine started, and then at high RPM in order to make the timing advance work correctly. As far as delivery goes, he has to meet that at several different RPM ranges, but he said really the most critical one is again the low RPMs, because that's important for cranking. If you don't have enough fuel there, you won't get the engine started. And he said that's one of the reasons why they like to set the roller to roller distance a little bit larger than the published specification to give you a little bit more fuel during cranking to make these older engines a little bit easier to start. And there's some adjustments he's going to make. He's going to set the low idle and the high idle. The high idle will be locked in. The low idle we may have to adjust on the engine. And then he'll check the timing advance and adjust that as needed. And he may have to adjust the transfer pump pressure. So in order to do that, he'd have to pull this black hose off and the fitting and then adjust that regulator but Corey's a pro. He's done this a few times before. I noticed he didn't really make any adjustments at all, and the pump was well within specification. So, clean bill of health?
Yep.
All right, man. You're a master of your craft.
You sure are.
All right, guys. Corey's breaking down the pump on the stand. It passed. Says it's good to go. He's fixed the problems I caused. Curtis, we can't thank you enough. It's been fantastic. All right, our rebuilt injection pump is installed. And I've hooked up the return line, but I'm not going to hook up this supply line because the inside of that fuel tank is disgusting. And it hasn't gotten any better in the additional year and however many months it's been sitting here. So we're going to run this thing off of my little portable tank here. It's full of clean diesel fuel. Just got it this morning. And we'll let the return run back to the tank, and then let's see. I'll siphon the stuff out of the tank first, and then we'll let the return run back into there. Shouldn't be that much coming out of here. Should be plenty there to run it for a while. Alright, change of plans. The siphon doesn't want to work, so we're just going to use the mechanical fuel pump here to pump the fuel right out into our catch can. That should get most of it. Anyway, I think we're ready to start bleeding this thing. The injector lines are loose. So, yeah, here we go. Alright, the throttle linkage is not connected, and the wire here is tying it at full throttle. Hey, got something on that one. All right, got 1 and 2. Alright folks, that's it. I'm out of capacity to store the old fuel, so whatever's in there is going to have to come out with the tank. But yeah, fantastic, it runs good. Alright folks, that's enough for today. It's getting dark, getting cold. My feet are soaked. I got everything packed out. I did get the fuel tank off, That was kind of a process. I'll show you guys when I go to put it back in. But hopefully I can get the old Ford down off of this snowbank. Alright guys, let's wrap things up. It runs. It runs good. It runs the way that it's supposed to run, and it hasn't done that for a very long time. I think it's been at least 3 years since that machine ran well enough that we could actually use it, and it's had problems for much longer than that. It would start and then it would die, and you had to keep babying it until everything warmed up, and then it would kind of snap out of it and you could use it, but then it would be just as hard to start the next time. And I'm sure that's all because of the contamination of that pump. You know, the elements inside, the governor weights, the metering valve, the delivery valve, the plungers themselves, they're all getting stuck because of that sticky contamination from the broken down fuel. And what I think happened in the last video series on this machine is that I should have been able to fix it by cleaning that injection pump. You know, cleaning all that stuff, freeing everything up, freeing up the stuck plungers, that should have taken care of the problem. But I introduced a new problem, which is that I set the transfer pump pressure too low with the regulator, and I didn't know that. And the transfer pump pressure has a cascading effect throughout the pump. So now you're not getting enough fuel during cranking, so it makes it hard to start. You're not getting enough fuel under load, so if we ever got it to drive, it probably wouldn't have had the power that it needed to have. And your timing advance isn't going to work correctly. So that is my fault. If I would have left that regulator alone, it probably would have worked okay. Although I'm not sure that it was adjusted correctly to start with, because it's always been hard to start. So it may have been a problem for a long time. I don't know. Anyway, I couldn't be happier with the job that Area Diesel Service did on that pump. I can't say enough good things about them. I really appreciate that they reached out to me, that they let us come down and visit, tour their operation, you know, watch the pump rebuild, film everything. How many companies would let you do that? I can't think of any. And we only saw a small part of their operation. They have another facility there in Carlinville where they do common rail injectors and variable geometry turbos. He said it's all dust particle controlled for cleanliness, and sounded like a pretty cool operation. We just didn't have enough time. Anyway, if you guys have diesel injection needs or turbocharger needs, please reach out to Area Diesel Service. I really don't think there's anything that they can't do. I will put all the contact details in the description box, and they specialize, I think, mostly in ag and industrial. They're pretty heavily involved in like tractor pulling, so if you have pumps that need modifications, like to add turbochargers or whatever, they can do that. And then you know, also of course they do rebuilds. They do a lot with Bosch pumps, Sanodyne pumps, Delphi, pretty much anything you can think of. Yeah. Thanks guys for watching, and if there's interest, I'll make a follow-up video. The fuel tank situation is not good, and we need some parts. There's a cable for the shifter, the reverser to go from forward to reverse that's frozen. I've got to replace that. And then we've got to figure out how to get the tire filled up without electricity down there. I don't have a portable compressor, so not sure what we're going to do about that. What else? I'm sure it just needs a general service. The oil hasn't been changed for, I don't know, probably 3 years. So we'll have to do that. And yeah, this machine should be good to go. I think operationally it's fine. It just had that problem with the engine. So yeah, we'll get it squared away and I'll film it if you guys want. If not, no big deal. Thanks for watching and I'll see you next time.